Welcome to Engineering Made Easy. I'm Lalit Vasist. Friends, in the last lecture we discussed various modulation techniques and we learned continuous wave modulation, where the carrier wave is continuous in nature, and we also discussed AM, FM and PM techniques of modulation. But now in this lecture I will tell you what is pulse modulation, where the carrier wave is in the form of pulses. We will discuss all these different types, PAM and PPM. So let's start. Okay, but first let me tell you one thing, that you have seen that in AM, FM and PM the amplitude, frequency and phase of the carrier wave varies respectively according to the amplitude of the message signal. I mean, in amplitude modulation the amplitude of the carrier wave varies, in frequency modulation the frequency of the carrier wave varies, and in phase modulation the phase of the carrier wave varies as per the instantaneous value of the message signal. Now we will discuss the pulse modulation. Let's understand the concept of pulse modulation. Pulse modulation, as we have seen here, that it is again of two types, analog and digital. Analog can be of two types, pulse amplitude and pulse time modulation. Pulse amplitude modulation and pulse time modulation. This pulse time modulation is again of two types, PWM and PPM, pulse position modulation and pulse duration modulation. It is also called as pulse width modulation, PWM. These are the same thing. So this example of this digital pulse modulation is PCM, as we have seen already, pulse code modulation. Okay, this is pulse code modulation. In pulse modulation the carrier wave is in the form of train of pulses. Okay, while in continuous wave modulation that we have discussed earlier, the carrier wave was continuous wave. You have seen that the carrier wave, this is the carrier wave, so it was continuous in nature, it is not in pulses, but in this case it will be in the form of pulses. So in pulse modulation the carrier wave is in the form of pulses, right? So now we will define the analog pulse modulation types. Here we will see what is pulse amplitude modulation, PAM, pulse width modulation, PWM, and pulse position modulation. After defining each of these modulation techniques, we will also understand these modulation techniques with the help of waveform diagrams. So first we will just define all the three types of modulations, PAM, PDM and PPM. These all three types. Let's define them one by one. After we will see the waveforms and will understand how does this happen, what is the exact difference and how things work. Pulse amplitude modulation, PAM. Let's take it first. So how can we define it? The pulse amplitude modulation is the modulation in which the instantaneous amplitude of the pulsed carrier is varied according to the message signal. The definition is quite same as the amplitude modulation. The thing is just that here the carrier wave which was in pulsed form, which was in continuous form earlier in AM, it is in PAM, it is in the form of pulses. The carrier is in pulsed form. Okay, so this is the definition. Now we will see the definition of another type, the pulse duration, also called as pulse width modulation. Later we will understand the waveforms of each type. Again, pulse time modulation. These two types are of pulse time modulation. What is PTM? In pulse time modulation, the pulsed carrier wave is varied on the time axis, that is horizontally. The variation is horizontal. Okay, the pulse time modulation is of two types, as we have seen. So let's define it. In pulse time modulation, so it is PTM is of two types, PWM and PPM. This is PDM, also called as PDM, pulse width modulation, and pulse position modulation. So let's see the definition of pulse width modulation, this PWM. In PWM, the width of the pulses of the carrier is varied according to the message signal. As you can see in all the examples or the types of modulation, we have seen that the thing that changes is the carrier wave, and it changes according to the message signal in each case, and the variations of the carrier wave, the changes in the carrier wave, are as per the name of that. If it is amplitude, then the variations will be in the form of amplitude. If it is frequency, then in the form of frequencies. And if it is if it is in phase, then the information will be contained in the form of phase changes. So here it is a pulse width. So the width of the pulsed carrier will contain the information. Changes will be in the form of pulse widths. So let's write it in PWM. So this is the definition of pulse width modulation. Now we will understand the definition of pulse position modulation, the next type, the pulse position modulation, PPM. So define this. Okay, so what is pulse position modulation? In pulse position modulation, the position of the pulsed carrier wave is varied according to the message signals. Okay, according to the message signals value. So I will again write the definition. In the pulse position modulation, so here it is clear again by the name, the pulse position modulation. The information will be contained in the form of position changing of the pulse. The information will be contained in the form of pulse positions. So up to this point, we have seen all the three forms of pulse modulation: the PAM, pulse amplitude modulation, pulse duration modulation, PWM, and PPM. So now let's start with the waveforms of these three modulation types. Here I am drawing the waveforms of a message signal. Now I am drawing the carrier wave, high frequency pulsed carrier wave. It is in the form of train of pulses. Also having constant amplitude. Let's draw the pulse amplitude modulated wave, PAM. Denote this by the CT, and this one with MT, as it is message signal. I denoted it with MT. Okay, as we know in pulse amplitude modulation, the amplitude of this carrier wave is varied according to the shape of this message signal. So in this case, as you can see here, it is the maximum amplitude of the message signal, and here it is the minimum. So the amplitude of this pulsed carrier will be maximum at this point and minimum at this point, and some intermediate positions at these other points. So let's draw it. Let's draw first the maximum and minimum positions to make it easier. This is the maximum, and say here it is the minimum amplitude, and here the amplitude is lower than this but higher than this one. So since these are the zero values, so the amplitude of all these 3 points shown here will be same, equal to this one. So this is the PAM signal, pulse amplitude modulation. You can understand it by the name itself, that the amplitude of this pulsed waveform, initially it was having a constant amplitude. It has changed according to the amplitude of this original message signal. So the amplitude has been modulated. You can also draw some intermediate amplitudes between these points. Okay, now we will see the pulse time modulation. As I have told you earlier, that pulse time modulation is of 2 types: pulse width modulation and pulse position modulation. So first we will see the pulse width modulation, which is also known as pulse duration modulation. Draw the diagram again. So this is the message signal, and here is the carrier wave in the pulsed form. As the name suggests, that pulse width modulation or pulse duration modulation, you know that in pulse width modulation, the width or the duration, you can say, of this carrier wave varies as per the changes or the instantaneous value of this message signal. So we will vary only the duration or the width of these pulses. In this case, we are not varying the amplitude, as was the case in amplitude PAM, pulse amplitude modulation. I am drawing vertical lines corresponding to some important points in this message signal so that it becomes easier to analyze. As you can see here, that here it is having the maximum amplitude of the message signal, and here it is minimum. So the width of this carrier, pulsed carrier, will be maximum at this point, corresponding to this point, and will be minimum at this point. If it is this at this point and minimum at this point. You should notice here that the amplitude is not varying, only the width is changing here, and corresponding to these 3 points which are at 0 here, the width will be equal. It will obviously be more than the minimum and less than the maximum pulse width modulated wave. You can denote it by ST, anything that you want. So now we will see the third type, the pulse position modulation, or also known as PPM. So again, for pulse position modulation, we will draw the same curve. Now, and you know that in pulse position modulation, the position of the pulsed carrier wave is varied according to the message signal value. So we will now vary the positions positions of this pulsed carrier as per the message signal. But important thing to notice here is that in PPM it is that its waveform is created with the help of PWM. This is very important thing, that to create PPM or pulse position modulation, you need the pulse width modulation. So I will show you how to create this waveform, but first you need to draw here the PWM for this case. So you know that PWM is, we have already seen, but the important thing now is that each trailing edge of the PWM pulse is the beginning point of the PPM pulse. It means that this is called the trailing edge. So let's see it first. What do I mean? These are the trailing edges. Trailing edges means this one, where it rises constant value and then it is down. So the point where it is finishing. So I'm drawing these dotted lines so that I can draw the PPM from PWM. So this trailing edge of the PWM would be the starting point or the beginning point of the PPM. It means that this will be the beginning of the pulse of PPM. Here I am not changing the amplitude, neither I am changing the width. I am just changing the distance between these pulses, or the position of these pulses on the horizontal axis. As you can see, the distance or the separation between these pulses is not constant in this case, but the amplitude is constant and the width is also constant. So it is PPM, pulse position modulation. So the PAM, PWM and PPM were the analog pulse modulation techniques that we have discussed. Now we will discuss the pulse code modulation, PCM. We have discussed PAM, PWM and PPM. Now we are going to discuss PCM, pulse code modulation, which is the digital form of this pulse modulation technique. Pulse code modulation, which is a digital pulse modulation technique. Okay, PCM is a digital technology using which it is possible to transmit any analog signal in the form of binary bits. Binary means zeros and ones. For this, the analog signal to be transmitted is first sampled using the sampling theorem. This sampled signal is then quantized. The quantization is a process where the sampled signal is cut into many levels and the value of the signal is rounded off to the nearest value of the fixed level. If you are not getting it, then I will explain it with the help of an example and a diagram. So you know that pulse code modulation is nothing but a digital pulse modulation technique. It is binary form, or you can represent the signals which are in analog form, analog signals into digital signals using PCM. Okay, using PCM, what you do, you can convert analog signals into zeros and ones. You need to use here two things: the sampling and the quantization. The sampling is based on the sampling theorem. It cuts the signal into samples using the sampling theorem, and in the quantization is at the amplitude level. So to understand it, we need to understand the concept of quantization and sampling. So I will draw. Okay, this is a signal and the time axis. Let's call the signal, denote the signal with yt, and here I will sample the signal with the help of sampling theorem. So how does this look like? I'm showing it here. The sampled signal is somewhat of this form. This has been cut horizontally into samples. So this is a sampled signal. I'm denoting the sampled signal with ST here. Now we will see the quantization process, how a quantized signal look like. So here is the quantized signal. I am denoting it with QT, quantized signal, and here is the time axis. For quantization, I have already told you the definition, and I have explained it earlier. What is quantization? Here we cut this amplitude into number of levels, and we try to approximate the value nearest to the, you can say that we try to round off the value of that signal corresponding to that fixed value of fixed level value. So here I am cutting this into some levels: 1, 2, 3, 4, 5, 6, 7, 8, or some levels in with the help of horizontal lines. Let's say that this minimum point is minus QP, and here is the QP. This amplitude is denoted by QP. So if there are L number of levels, then L, if I'm cutting it into L levels, then L is the number of levels, okay, and 2 times of QP. You can see this is QP, and here it is again the QP. The QP and QP becomes 2 QP is the peak to peak amplitude, okay, it is peak to peak amplitude. And so you can say that 2 times of QP by L, 2 times of QP divided by L will be the magnitude of each level. Magnitude of each level. So what is 2 QP by L, or the magnitude of each level? This is the 2 times of QP divided by L. This distance or this distance, these all are same distances. So it is clear that as the number of levels increases, the accuracy of the quantized signal increases. The quantized signal is just an approximation of the original signal, so we can say that as the number of levels increases, it implies that accuracy of the quantization also increases. Okay, so you can increase the accuracy of signal, the quantized signal, to any desired level by increasing, or you can say by varying the number of levels. Higher the number of levels, higher will be the accuracy. The PCM pulse code modulation uses this technique to convert analog signals into digital signals. Now let's see how does a PCM wave look like. This is 1 0 1 0 0 1 0 0 1. As you can see, this amplitude represents level 1, so all these are 1, and here this level is 0, so continuous 0 0 levels, you can see it. So this is the PCM pulse code modulated waveform. Okay, so now you know various kinds of modulation techniques, including amplitude modulation, frequency modulation, phase modulation, pulse amplitude modulation PAM, pulse width modulation PWM, pulse position modulation PPM, and also the pulse code modulation PCM. So please let me know how did you like the video, and your suggestions for the improvement are also welcomed, so that I can help you in a better way. You can also write comments regarding your queries too. Friends, for more such videos you can subscribe my channel Engineering Made Easy, and please don't forget to like and share the video if you liked it. For more detailed information, you can visit my blog www.engineeringmadeeasypro.com. Its link is given in the description of this video. You can check it, and see you soon in the next video. Till then, bye bye.